on our website. Some of you already have done so, and follow the project also on LinkedIn and Twitter to keep in touch with us and get frequent updates on the project. So that's it, I believe. I now pass on to Daniel. If you have questions all along, please enter them to the chat box or raise your hand after that. And now enjoy. Thank you.
Yeah, thank you, Thomas. You can pass on the next slide. So I'm Daniel Novak. I work, as Thomas said, in Airbus Defence and Space, the space part of it, in Toulouse, in the future Earth observation programs. And I will present you the vision around these dominoes. And first, we need to imagine that we place ourselves in the world of Earth observation market. You probably heard, I'm sure, of Copernicus, big European program. There's many other commercial programs or services for imaging the Earth, commercial, but also countries buy as well their own satellites and their own ground segments to image their areas of interest, their countries. There's also military market. So there's this market of Earth observation systems is really growing, and it will continue to grow more and more. And when we look out, we see a couple of trends which are quite inevitable. So the first one is what I said, is that this market will grow. More and more companies or governments or military entities will endow themselves with their Earth observation imaging system. But then also we'll see, as the number of these grow and their capabilities grow, generally we will see that these systems will be more and more connected between each other. There will be heterogeneity, so there will be capacities between imaging in visible bandwidth or in radar or infrared and so on, and all these imaging capabilities will be more mixed up together. The systems will be smarter and more reactive, partially because there will be antenna networks to communicate with from the satellites, enabling more reactivity to send up requests and receive the images. Smarter because there will be more intelligence on the ground or on board to make decisions whether to acquire or not acquire, or reprogram itself and so on. The systems will evolve faster, so they can be replenished or updated and so on. And the ground, the infrastructure will run more and more in cloud environments, but because of certain restrictions, typically export control, parts of them, if it's in the cloud, it has to be in sovereign cloud. So it's also, generally speaking, in the IT world, a topic that is of increasing importance. These ground segments and generally the systems will more and more have as a service business models as well, be it for antenna booking or for maybe archiving images or other things. Some customers around the world, typically outside the European countries, they want to gain knowledge, increase the country's capabilities, so they want to have more and more local content, local developments, local technologies integrated into these systems. So we have to be ready to propose something to them that that fulfills these wishes. As I said, there's more and more security and export control regulations that must be accounted for. The delivery times will be accelerated, and globally, the economic equation for building, running, operating these satellites and these systems will be a bit more complicated. So this is the trend of the market, and we also see that outside Europe there's quite a lot of competition and the increasing number of very capable actors. Typically, what I wrote here: USA, China, Israel, Japan, South Korea, just to name a few. There are others as well. So the competition to build these systems is increasing. And yeah, our interest is to Airbus as a European company with European roots is to get the best innovations, but the most competitive products and services that we can integrate into our systems and sell them to customers around the world, and which with these innovations we think it is important to make a difference compared to the competition. You can go to the next slide. So a couple of points that will help us boost competitiveness. So we are looking into, as the diagram shows, the systems that will be heterogeneous, connected, reactive, and so on. So as I said, we have to make sure that all new ideas, competitive ones, are quickly brought to market and integrated into the large end-to-end system that is sold. And one important way to achieve this is to have ground segment architectures that have a breakdown that is standard, with interfaces that are standard, so that new bricks can be added on as easily as possible. As an industrial setup, it is important to attack the market in a consortium with, as I said, the best in each of the parts of the ground segment. And so we can then therefore leverage also on all the big investments that are made otherwise from public or private sources into this ground segment ecosystem. And so this boils down to a couple of challenges. So we have to master the complexity or upcoming complexity. So for that, we will have these standardized interfaces. We have to address the federation of these heterogeneous systems in a reactive manner. So Domino-E will be key in this. Automation, very important, because as we increase the number of assets that are flying, the number of operators normally increases as well. So there's automation topics that we are addressing. The reactivity via ground station as a service, as I mentioned, and by applying artificial intelligence to extract information from images, typically like to see objects flying, objects, sorry, on the Earth. And also we need to look in the sovereign cloud deployments, not only from technical perspective, but in terms of administrative, in terms of export control, licensing, protecting the assets, and so on. So you can move on. Next slide, please. Thank you. Just a broad overview on the Domino-based ground segment. So it is ongoing work. So we're looking at the ground segment that is based more or less on 20 or 22 dominoes. A domino, what we call here, is a functional brick in the ground segment that is as loosely coupled as possible from all the others, that may run on its own IT infrastructure and may be provided as a service or not. And the interfaces, what is important, the interfaces must be standard, so we can pull and plug these dominoes and implementations of these together as easily as possible. So there's important work going on together with the number of companies, including Thales Alenia Space, Safran, Capgemini, CS Group, and so on, to work on a standardization of these interfaces. And we are also engaging with institutions like European Space Agency or EUMETSAT and the European Commission to embark them on this domino model, which we believe is the really tool for moving on and attacking these challenges ahead. So there's an engineering model for these that is being worked on. It will be public, and the modeling tool itself for this engineering model is also free and public, and it's Capella. It's a tool from Thales. So you can move on. Next slide. So first part, I just wanted to say that okay, this domino model of as autonomous possible bricks with as standardized as possible interfaces is really key, because that will address both the variability of the needs, the need to combine systems in the future. By having standard interfaces, it will be easier to integrate everything together and then lower the barrier to entry into the ground systems domain. And also by decoupling different parts of the ground segment, we can also leverage on different IT technology cycles that evolve at different paces, different temporalities, and we can therefore serve those waves better. You can move on. And then one more. And now I will focus on the Domino-E, which looks into the federation services. Observation as things stand today. As I said already today, there is quite a few different kinds of systems already flying and making acquisitions. They can be like commercial imagery providers. Airbus is also a commercial provider among them. There are some legacy systems otherwise that belong, for example, to a certain government somewhere. A government might buy a new system as well. There might be even third-party government systems from other governments or entities. And so all these, ideally, a customer will want to link together and get imaging capability from all of them. And we have to imagine that in the future there's HAPS systems as well. And so these high altitude pseudo satellites flying 20, 30 kilometers above sea level, and also equipped with imaging. But today there's quite some heterogeneity. There's no real good solution today to have a reactive tasking of each type of satellite in a federated manner. So this has a repercussions, obviously, on operational costs, on ease to upgrade, on possibility to optimize the mission objectives, and so on. So you can move on. So in Domino-E, we want to address this, and we're focusing on this federation layer, which will involve a couple of new things, including new algorithms that will allow to dispatch requests between different kinds of sensors. So all these different kind of systems that I listed before. There will be therefore technical feasibility studies as well within the system, so with some algorithms associated to them, and there will be developments and a demonstration of these by the end of the project. And by doing this, we will make sure that we will achieve in a federated system, a system of systems, this reactivity, the persistence, and the precision and costs that are unnecessary. You can move on. So I will finish on this slide. So you see the previous system types that are already exist and we will exist in the future. And here we, in a way, we will work on this kind of federation layer, or you can call it federation services as well, which will address different use cases, typically the coverage, so large area coverage service, where we will make sure that a large area is mapped and imaged by the various different systems according to the needs of the client. There's also work on improving and having more reactive way of booking antennas, ground stations, to have a very reactive operations, so we can uplink to an asset, a satellite, an imaging request as fast as possible, and bring down the acquired image as fast as possible, so that this can be processed and eventually analyzed with artificial intelligence and pushed to the end user. And also the third pillar in this project for us is this virtual assistant, which will also help the end user to input requests for imagery into the system in a very, let's say, natural way. Especially important because not all users will be familiar with all the technical parameters that need to be set in such complex systems, and this will help a lot, let's say, in terms of reactivity and user experience. So this concludes my part, and I guess if you have any questions later, then I think it's in the end of the hour. If I understood correctly, Thomas.
Absolutely, yeah. We put all the questions in the end of the session. I hope that's the most convenient way of doing it for all of you. So keep your questions towards Daniel if you have some. And thank you, Daniel. I'd now pass it on to Gauthier of Onera, who's sharing his screen himself.
Yeah, good afternoon, everybody. Do you see my slides?
I think we do, yes.
Yes.
Yeah, that's fine. So, and thank you, Daniel, for the last slide, which will be the start of my presentation. We didn't coordinate that much on the presentation, but in the end, we matched. So I'm here to briefly overview the different challenges in Earth observation, especially in the Domino-E context, and the AI and decision focus that we are doing at Onera, especially in designing the federation layer. So first, so Onera is the Office National d'Études et de Recherche Aérospatiale. This is a French aerospace lab. So we are public establishment under the supervision of the French Ministry of Armed Force, and we, especially in the context of this project, this is the Department of Information Processing and System, which is involved, and we will develop artificial intelligence and decision techniques within the Intelligent System and Decision unit, research unit, which is in Toulouse, here in France. So let's start from the previous figure that Daniel presented about the different bricks that are composing a mono mission or multi-mission managing system. So initially, we could say that single operators are able to may operate several missions, but in the end, if there is several missions, but all owned by the same company, this isn't that much a problem. One problem may happen when you have to book and to try to decide which mission you can use for a particular request, especially if you want to acquire a large area on Earth. You may want to, maybe you can use a single mission, so single constellation, where you know exactly the sensors, they are all the same, you know exactly the orbits, and you know the property of the sensors, so that you can address this coverage problem quite simply. And as Daniel just presented, fostering the use of ground segment as a service is also an opportunity to improve reactivity in your system. So the idea is that the federation layer that we will develop here will book the stations so that it will be possible to improve the data, increase the data freshness. That is to say, to the downlink will be as soon as possible, sooner than by using legacy ground stations, and also to push plan, so the uplink to send plans to satellites. So Onera will mainly focus on the coverage service and the communication booking service here. Still, there are other research topics in the virtual assistant one, so I won't detail this, but our colleagues of Tilde, I think that someone is here in the room, can be asked for questions later on. So the idea with the multi-mission is that it is possible that some of the missions won't be proprietary or won't be legacy and will be completely external to the initial system. So you will have, for instance, if you want to acquire a large area requiring to query some of satellites of this external constellation, you need to find the proper way to coordinate and to query these stations, knowing, and even more, if you have several constellations in this case, you need to try and find a way to coordinate your queries. So the first thing that one may want to do, if you have a large area, is to split this area into a smaller one so that you can query different missions or different satellites to take pictures of the smaller areas. So this is a classical problem even for proprietary, for a single mission, for instance, with several satellites. And one way of doing this, it strongly depends on the sensor on board, but here is one example. So you want to acquire the south of France to monitor, for instance, fires during the summer. So one thing that you can do is to split your large area into 2D strips corresponding to the footprints of the satellites on Earth. And if you have, it can be done by a single satellite, so it depends on its orbit parameters, but you can also divide this between several satellites of the same constellation, or you can even do what we want to do in the Domino-E project, is to split into different missions so that you improve the reactivity of your system. That is to say, you will get your images sooner. But now you have a kind of an allocation problem to solve, which is how do I split my large area, and which mission will acquire a given smaller area. So this is an allocation problem. It's not so that easy, because you can revise the way you are dividing your area into sub-areas. Which depends on the characteristics of the mission, depending on the sensors, depending on the orbits. So you have many ways of splitting, many ways of allocating. For instance, allocating each area to a different constellation. And of course, you want to do this under some operational constraints, under some quality constraints about the images, maybe about economical constraints, depending on how costly it is to query some images to a given constellation. Or it can be also only quality of service constraints, for instance, the date to receive your images. So another problem is that if you are not operating by yourself the constellation, maybe you are not aware of when these images can be done, and if the constellation is able to perform your images on time. So that means that you want to split your large area into several areas and to allocate the sub-areas to some missions, but you are not sure that these missions will accept or will provide you the images on time. So the idea is that you need here to assess what is the load of each mission. So if these are your own missions, that's fine. You can know what are the different schedules and the plan on board. So maybe you can have this load. But if you are querying an external mission or a tier, you need to assess the load of this mission depending on different interaction you may have before. Or even simpler, you want just to predict what will be the mission response. For instance, I want to acquire a specific area around Toulouse. Will this mission answer yes or no on time to get my image on time? So that means that you need to simulate the request and answers process between the client and the mission. And to learn the distribution of yes and no, or of time to fulfill, or many other parameters, and to use distribution to guide the allocation process. So you have this cycle between I want to decide how to divide my area, how to allocate the different sub-areas to missions, and these missions, depending on some probabilities you learn on these missions. So this problem falls into the framework which is called the multi-armed bandit, which is a classically known machine learning framework. And in Domino-E, we will develop techniques to solve such problems. Now you have your plan, and you split all your sub-areas, and you have the allocation to the missions. Maybe you want to know when you can get you can download your data on Earth. Of course, satellites don't have permanent access to ground, to communicate with ground, so you need to book communication stations. So most of the time, if you are in a legacy system, with your mission, you have the legacy stations you can use for uploading and downloading your data. But here we want to explore another paradigm, which is using ground segment as a service. That means you have service providers who have stations on Earth that you can book for some specific communication with satellites. In a very reactive way. The idea is that you can book them as soon as you want, or you expect to, so you can push plans to the satellites. For instance, if you want to make some urgent request because you have detected a fire in a forest, and you want to monitor this area more precisely, so you can ask for other requests, other images in an urgent way. So the idea is that we want to foster the use of ground station or ground segment as a service to improve reactivity here, as Daniel emphasized just before. And here, the problem is that you want to allocate again ground station, or more precisely communication windows with the stations. That costs money. Of course, if you want to book the station, you need to pay for that. So you will have some compromise to explore between reactivity and the costs of this reactivity, depending on if you are overbooking the stations, or if you want to book at the last minute, but maybe that requires a lot of money, or maybe risk that the station is overloaded and you cannot book it. So there are many compromises to explore. And in the end, to explore these compromises, you need to assess the load of the stations and to predict the service response, yes or not. I can. Is it possible to send data to the satellite, or is it possible to book downlink? So as for the mission plan and the allocation of sub-areas to missions, the idea is that you need to predict the behavior of the ground station, to simulate request and answer, and to learn the distribution between yes or no. If the price is variable, maybe you can learn when it is better to book the communication window with such a service, and to use this distribution to guide your decision process about which time communication window you will book. And again, we fall into the multi-armed bandit framework that we will explore in this project. And of course, your plans for splitting the different areas into sub-areas to missions, and then to book the communication windows are very linked together. And so this is why we need also to explore the interlink between these two dimensions, and so that we can build this multi-mission federation layer. So we want the two services, coverage service and communication booking service, to be as interactive as possible, so that both mission planning and communication booking are done all together in the most optimized way. So to sum up, we have mainly two research tracks here about multi-mission coverage, feasibility, and dispatch service, where the main issue today is that one satellite is not enough for extended coverage with time and quality requirements. This is why we want to split the different acquisition between different missions. And we have the multi-mission communication booking service, where locations of dedicated stations defined during the program and for the mission of the whole are done for the whole life of the system. So it's not that much flexible. So we want to address reactivity using ground segment as a service. And the idea here is that we will provide some dynamic station reservation capacity with the communication booking service. Both are strongly based on machine learning and AI and decision techniques that we have developed at Onera for predicting the third-party features and behavior, verifying the third-party capabilities, optimizing the user cost and performance, and adapting to the changing environment, for instance, for weather condition that may invalidate some images, or even for urgent requests arriving at runtime. And we are developing artificial intelligence and operation research techniques here at Onera to address these scientific questions. So the scientific team behind this will be composed of myself, of Cédric Pralet, Jean-Loup Farge, and Filippo Perotto. I think that yes, Jean-Loup and Cédric are here, so you can contact them also, and they will be open for questions in the Q&A session later on. And importantly, we are hiring a full-time researcher, postdoc for 24 months to help us in this research task and implementation task and demonstration task, since at the end of the project we want to demonstrate these techniques on the deployed system. So if you know people that could be interested in making research with us, we are very open for that. And that's all for me. I hope that I'm in time, and we will have time for questions later on. Thank you.
Fantastic. Thank you, Gauthier. Who would have guessed that this webinar also comes with a job offer? Paola, it's your turn now. Do you want us to share your slides, or do you want to share them on your own? What's more convenient for you?
Good afternoon. I can share the slide myself if it's fine with you. Okay, thank you very much, and good afternoon, everyone. I'm Paola Testa, and today I will tell you more about the company I work with and our role within the Domino-E project and the expected impact and the commercial outlooks of the Domino-E project. So I work for a VVA, Valdani Vicari and Associati, which is a consulting company that was founded in Italy 30 years ago by two professors of Bocconi University. Basically, we offer services in multiple sectors, among which telecommunication, digital and space, the domain in which I work, but also many other like social policy, research and innovation, the consumers and the single markets, and many others. We tend to perform market analysis, market assessment, both qualitative and quantitative, cost-benefit analysis, ex-ante and ex-post policy assessment. And within the Domino-E project, we will be leading the commercialization analysis of the Domino-E solution, together with the development of the exploitation and strategic roadmap of the technological solution, on top of contributing to the user needs assessment and the use cases definition. So, as always happened, of course, we started from the state of the art. So what's already out there when it comes to Earth observation in Europe, precisely, but also worldwide. There are some needs from the operational standpoints. My colleagues already provided a lot of details of the system that are already available and the challenges. I will summarize what is relevant from the commercial perspective, which is for sure responsiveness, because when a user rely on EO data to pursue a certain objective, the time and therefore the money that it takes to get what they need, it's fundamental for their solution and their work to be effective. Revisiting and also other technical parameters are of course fundamental and needs to be met to reach the objectives. And since nowadays multiple constellation, multiple missions and multiple kind of data are available, fully exploiting the complementarity of those available missions is fundamental to avoid overlaps and maximizing the effectiveness and of course also the economic return of the existing missions. Then moving to the users now tend to look for and to try to develop solutions that are first of all rapidly operational, because if it takes too long to develop something that you know it's useful, the market you will move on and you will just lag behind with the solution that was useful just when you thought about it, but then the implementation took too long. So this is very fundamental. The solution proposed needs to be, of course, competitive in the current landscape and easily scalable, because of course we are focusing on the EU environment, but the satellite system have global coverage and the competition is also at global level. So the scalability is really fundamental for success. A major issue that the users are also facing is fragmentation. Fragmentation when it comes to accessing the EO data or products they need. And therefore, they more and more seek systems offering an automated acquisition of image. Of course, relying on artificial intelligence and digital tools. So Domino-E is meant to satisfy these needs that I mentioned, both from the operational and the user perspectives, by the development of the federation layers that will offer easy coordination and a smart prioritization of the different available systems. This implies that all the existing missions will be more valorized, while the manual effort will be reduced. So it's really a win-win. And how can this be reached? By the setting up of a system that needs to be modular, flexible, and resilient, which means that its performance does not degrade as the number of provider on one side and user on the other side grow. So the objective of the project overall is to demonstrate the feasibility of this multi-mission federation layer, both from the technical and from the commercial standpoint, as this layer is meant to act as a sort of one-stop shop, as an hub, addressing indeed the existing fragmentation, which is a major barrier to unleashing the full potential of the European industry. So how Domino-E intends to foster the competitiveness and innovativeness of the EU industry in Europe is by creating a connection between three main players, which is the industry on one side itself, public institutions, and researchers. Why so? Because it has been demonstrated by the literature that the connection, a strong connection between these three players is really of key importance for the creation of an innovative ecosystem with self-renewal innovative capacity that is sustainable over time, which means that it's able to adapt as the user needs change, the market change, and the technology evolve. So it's really fundamental to create something that is able to offer benefits today, but offer benefits that will last because we'll be able to evolve. Then, starting from the industry, Domino-E is focused on the ground segment, as we know, and the ground segment is just a small component out of many other of the entire EU system. Still is a very fundamental one because it's the first interface to the user. It really connects the system itself to the user, so it's really important because it needs to be functional and also easy to use somehow. For this reason, the modular structure is fundamental to be able to include all the available mission or as more missions as possible to provide the best possible offer. In doing this, Domino-E will have an inclusive approach towards the EU industry, which means that it will try to get on board every kind of industrial stakeholder, so from SMEs and startups to the big players that we all know. And in this way, we'll create an ecosystem of service providers that will closely collaborate with each other. And of course, this collaboration implies a significant effort towards standardization. So this is an important challenge that we are aware of. And therefore, in this way, the expected impact of Domino-E on the European Earth observation industry is first and foremost, increased competitiveness. Competitiveness is practically translated into increased productivity, better exploitation at downstream level of all the products and services that will are made available and then used through the federated layer, a more efficient management of the fleet of satellites, which means better economic return out of those, and connection between different players from the industry, starting from the startups and SMEs. As we all know that the small players are the ultimate source of innovativeness of an ecosystem, so they are very vital for all of us. But sometimes, since they are so small, so due to their very dimension, they struggle to access a bigger system or to interact with the big player. So we intend to really create this link on a permanent basis. This will lead the operators to be in the position of better reply to the request that they receive from their users in terms of completeness, timeliness, and for a lower cost. And in turn, large-scale integrators and bigger players will enjoy complementarity with SMEs and startups that often they struggle to reach. Then moving to the public institutions. Earth observation today already plays a very important role in supporting the public institution in the definition, planning, deployment, and monitoring of multiple policies. Here you can see really a short list starting from the Green Deal, which is of course a hot topic and will be of course in the coming years, but also everything that is related to civil protection, safety and security, emergency management, the common agricultural policy, which is really a big share of the EU budget, for instance. So they are really many. And what Domino-E will offer to the public institutions is the opportunity to take better informed decision making, which means the development of better policy and a more effective monitoring of the policy implementation. Thanks to more and better and more frequently updated data that covers all the relevant domains. And this imply an optimization of the public effort, so better spending of public money. That it's, of course, it's a benefit for all of us, for all the European citizens, and in turn also a more competitive public procurement. For instance, for contributing missions. Then, last but not least, the research community. A piece of research to be successful needs some fundamental ingredients. First of all, the data. Both quality and quantity needs to be there. Collaboration between researchers, it's increasingly the rule. And being in constant touch with the industry on one hand and the society, the wider society on the other one, to be aware of the hot topics that are going on in a certain historical period, so to know what to look at, what to research, and how they can contribute to the society. Domino-E will offer them easier access to more and better data. So something that is really fundamental for research, leading therefore to a wider knowledge base that will make the European research community more competitive, both the research taken individually, but most of all over the global arena, and also more independent, of course. This will enhance collaboration both within European researchers and with the external ones. And the links with the government and with the industry that Domino-E will build will also provide somehow more visibility to the researchers that will be likely translated in increased recognition of their role, which is indeed very important. So as of now, where we stand, we are in the initial phase of the project. So preliminary activities have started, but still it's a long way because it will be a long project, very complex. And for all the activities that concern the market assessment and the development of a strategy for the actual deployment and long-term sustainability of Domino-E, we intend to perform multiple consultations. And here the engagement of stakeholders is fundamental for us to obtain robust results. when it comes to the finalization of the assessment of the state of the art, the continuous monitoring of the user needs and the gaps, the definition of the value proposition that Domino-E is going to offer to all the different kind of stakeholders to ensure its commercial sustainability, and finally also to validate the findings that we will achieve. We will need absolutely to rely on external stakeholders. So I take the chance now to encourage all the participants to subscribe to the newsletter of the project to be updated. And we will be most grateful if you will be available to participate in our consultations. This is it from my side. Thank you very much for your attention, and I'll be happy to answer to your questions, if any.
Thank you, Paola, and also thank you to Gauthier and Danielle again for your presentations. I think this was very interesting and also promising in a way. And I'll now open the floor for any questions or remarks by the audience. And I'll give you a moment to, well, get yourself settled, unmute yourself, and raise your hand.